All right, so today's topic would be the second fundamental theorem of calculus. You remember the first one, we've done so many problems on the FTC one. So the second FTC is even easier. So let's say we have a function, f of t. I'm going to actually tell you exactly what it is. It's 4t minus t squared. Now, we need to use the following integral from 1 to x, some kind of unknown variable, f of t, which is our function, dt, to find capital F of x. And we also want to find, you know what, let me just write it down, what I'm trying to do. So I want to find f of x, and I want to find f prime of x, which is the derivative of this. All right, so we have this formula, and let's follow it. So in order to find f of x, we're going to consider this integral from 1 to x. We're going to plug in, you see it says f of t, so our equation, and 4t minus t squared. Do not forget dt. And now we're just going to solve it the regular way. What's the integral of 4t? It's 4t squared over 2, right? What's the integral of t squared? It's t cubed over 3. And the boundaries are 1 and x. So we get 2, you know what, let me just erase this part right here, because we already know we're getting 2t squared. I just want to simplify it right away. And now we get, let's plug in. We're going to plug in the upper boundary, which is x. So we get 2 times x squared minus x cubed over 3 minus, let's plug in the 1 here, the lower boundary. That would be 2 times 1 squared is 2, minus 1 cubed over 3. Okay. So now I get 2x squared minus, I just want to make it pretty, I'm going to put 1/3 x cubed. Now, if you distribute the negative, so you'd get negative 2 plus 1/3, you're going to get negative 5 over 3. So that's it. We just found f capital of x. Now we need to find f prime of x. Okay, so I'm just going to copy our result. F of x, we got 2x squared. We got minus 1/3 x cubed and negative 5 over 3. So the derivative of this would be what? 4x minus 1/3 times 3 is 1, x squared, and that goes away. Now look at this very carefully. You see this 4x minus x squared? Now go back. You see right here, what's your given function? 4t minus t squared, but we got 4x minus x squared. Do you see some kind of pattern here? If not, let's do one more. I'm sure you're gonna catch it now. So f of t equals cosine of t. Again, they want us to use that main formula, f of x equals, I'm just gonna copy it, f of t, the original function, dt. And then we're gonna find the derivative of that. Okay, so f of x equals integral from 1 to x, and we're gonna put cosine of t dt, because that's the given function, right? Integral of cosine is sine of t, and the boundaries are 1 and x, and we're going to plug in sine of x minus sine of 1. You can use your calculator or you can just stop here. Now let's find the derivative of that. Derivative of sine is cosine. And since this guy right here is just a constant, so we get nothing, the minus 0. So now look at this, and look at your given function, cosine of t, but we got cosine of x. Do you notice anything? I hope you do. So now we're going to summarize it in a second. Now let's consider another function. Well, it's going to be my example number 3. F of t equals t cubed. Now, we're going to use the following formula. F of x. Now, from 1 to, and instead of x, we're going to put x squared. Make it composite. And the same thing. So again, we want to find f of x and the derivative of that. So based on this formula, we get integral from 1 to x squared. F of t is t cubed, so let's plug in. And let's solve this integral. So what's the integral of t cubed? It's t to the 4th over 4. And the boundaries are 1 to x squared. All right? Now we're going to plug in the x squared. We get x squared, but the whole thing is to the 4th over 4 minus, now let's plug in 1 for t, so it's 1 to the 4th over 4. So we get x to the 8th over 4 minus 1 over 4. Okay, now let's find the derivative of that. So the derivative of that would be, you can rewrite this as 1/4 x to the 8th minus 1/4. So when you take that 8 and bring it down, so you multiply 1/4 by 8 and you get 2x to the 7th, and negative 1/4 prime is nothing. It's just 0. Okay, so look at that. Now I'm sure you're probably trying to compare it to this one, but we're gonna move on. Let's just you know what, do your thing, follow my steps. Now let's do one more example, see what happens next. It says f of t equals 6 square root of t. Now based on that formula, again, my upper boundary is not going to be x, it's going to be x squared, the composite functions. So integral 6 root t dt from 1 to x squared. And we get, you know what, I'm just going to rewrite it. 6t to the power of 1/2 dt. We get 6t. Now 1/2 plus 1 would be 3/2 over 3/2. We're going to flip it in a second. X squared and x. So that becomes 2/3 times 6 t to the power of 3/2, which is just 4 t to the power of 3/2. Now we're going to plug in x squared. We get 4x squared to the power of 3/2, and then minus 4 times 1 to the power of 3/2. So finally we get 4, this is algebra 1, x to the power of 3 minus just 4, right? So that's what I got. That's what I got. Now the derivative of that would be 4 times 3, 12x squared. So that's our derivative, and that was the original function. That was our derivative, and that was our original function. Now, the second fundamental theorem of calculus, the FTC 2, says, if f of x equals the integral from a, some kind of value, constant, to we're gonna express the upper boundary as a function of f of t dt, where a is constant, then the derivative of this function is simply f of, now instead of t, I'm actually going to plug in this function, the upper boundary, which is g of x, times, since it's not just the upper boundary, it's not just x, but it's g of x, makes it composite, so you sort of need to apply the chain rule, kind of. So it's a g prime of x. So that's your FTC, FTC2. Now, back to your examples. Remember those 4, I think, examples we did? So I want to talk about them again. I don't know. I hope you were taking notes, because I want you to see those examples in front of you. I can actually copy. The first one was f of x. Okay, so that's the formula. And the equation was 4t minus t squared dt. Now, remember from that first page, we found the derivative. And we got, let me go back to check. Is that the function we had? Yes, 4t minus t squared. And then we found the derivative, and we got 4x minus x squared. So that's what I'm going to put here. In the second column, 4x minus x squared. Now, let's apply the FTC here, the FTC2 that I just explained here on the previous page. So based on that FTC, I'm just going to copy it. It says when you have a function f of x, the integral from a constant to some kind of function, and you have f of t dt, the derivative of that is simply f of, replace t with whatever the upper boundary is, and if it's composite, multiply by the derivative of that. So let's apply that. So a function is given for t minus t squared, right? And we just want to find the derivative of that. So we simply replace t, we replace t with x, and then multiply by the derivative of x, which is 1. So let me write it out. So f prime of x equals, you replace t with, upper boundary is x minus x squared, but then you're supposed to multiply, it's like a chain rule, multiply by the derivative of your upper function, which is 1. And that's how you get 4x minus x squared. So you don't have to go through that long process. Remember what we did here, and there, and it takes forever. So if you apply the FTC2, you're going to get the same thing. Now remember that second example we had. I think it was, no, actually, let's do the third one. F of x equals integral from 1 to x squared, and I think it was t cubed dt. So in order to find f prime of x, you're going to apply the FTC2. You're going to replace t with your upper boundary. It's a composite function. So t is x squared now, but the whole thing is to the third. But then you have to multiply by the derivative of x squared. So eventually you get x to the 6 times derivative of x squared is 2x. And your result is 2x to the 7th. And if you took notes, you can go back and check, and we actually did have to follow that long process to prove it. But now you understand, you can just apply the FTC2, and that's it, and you get your answer. So now let's practice a little bit. So if you need to pause, if you want to do it by yourself, pause it and try it by yourself, and then, play the video and compare your result to mine. All right. practice. It's easy stuff. F of x equals integral from -2 to 2x, the square root 2 minus t squared dt. So we're gonna just take this and plug it in. So the derivative equals square root 2 minus, and instead of t, we're gonna put 2x, but it's squared. And then we need to multiply by the upper bound prime. The upper bound is 2x, prime gives us 2. So we get 2 square root 2 minus 4x squared. And we're done. That was quick and not painful at all, right? Let's do one more. It says g of x squared negative 3 e to the power of cosine t dt. Here's the problem. Before you apply the FTC2, you need to make sure on the bottom, as your lower boundary, you just have a constant. And if you don't, then you need to flip it and put a negative outside of your integral. I hope you understand what I mean. So I want to see constant on the bottom. When you flip your boundaries, you put a negative sign outside. So nothing really fancy happened here. So we're gonna find the derivative of that function. Negative remains negative. Now we're gonna replace this t with x squared. So we get e to the power of cosine x squared, but we need to multiply by the derivative of x squared. Let's pull it out. So we get 2x, e, negative 2x, to the power of cosine x squared. I hope that makes sense. Okay, next example. So we have this function. It's a g of t. Now, at the same time, they tell you that f of x, it's another function, equals to the integral from -4 to 2x of that g of t dt. Now it says find the value of f of 0. Well, that's easy. You just plug in 0, right, for x. So we get integral from -4 to 2 times 0 is 0, g of t dt. The lower boundary is on the bottom, 0 is on the top. That's good. Now we don't have any equations, but we have a graph. So we can use a little bit of geometry here. So from -4 is here, all the way to 0 here. So we can actually get rid of these two. They cancel each other. Now we can do this thing right here. And by the way, that's a terrible drawing, but forgive me. This is 1 and this is actually 2. So the radius is 2 units long. So in order to find the area of this semicircle, right? But we don't need the whole thing. We just want a quarter. Because it says all the way up to 0, so from -4 to 0. So we just want this quarter. So we're going to do 1/4 pi r squared, but the radius is 2, so 2 squared. And also there's another triangle right here on the bottom. You see that? So we need to find the area of that. That's length times width. So that would be 1 times 2. Here, 2. So we get pi plus 2. I hope that makes sense. I hope so. Part B, it says find the value of f of 2. So you're gonna, again, consider integral from -4, if you remember, to, let me go back. You see this integral they give you? F of x equals integral from -4 to 2x. So we're going to replace x with 2, right? So 2 times x, 2 times 2 is 4. So it's from negative 4 to 4, g of t dt. All right, so we just need to find the area under the curve between negative 4 and 4. So I can just do this right away. I can get rid of these triangles. Let me just physically get rid of them. I can get rid of these triangles. Oh, wait, just want to make sure. This is 3, right? From 3 to 4, 3 to 2, yes. And this part is also gone, so we can get rid of that. So we end up with the semicircle and the rectangle. Semicircle would be 1/2 pi, r is 2, so it's 2 squared, plus length times width. So that would be 4 times, and that would be 1. So we get 4 divided by 2 is 2 pi plus 4. I hope I didn't make a mistake. C, it says find the value of, no, it's the derivative of this function f of t, but at 1. Let's see, I want to copy this. F of x, the given function, it's integral from negative 4 to 2x, I'm sorry, g of t. So in order to find f prime of 1, you need to find the derivative of this function first. That's the FTC too, correct? We just talked about it. So all you have to do is replace t with the upper boundary to 2x. So we get g of, it's not t anymore, it's 2x, but times the derivative of whatever is on the top. So derivative of 2x is 2, so I'm going to just put it in front. G of 2x. Now it says find f prime of 1, so let's plug in 1. So it's 2 times g of 2 times 1 is 2. This is a function of g of t. Now we just need to find g of 2. But g of 2 is, I think it's 1. Let me see. This is 2. And this is 1. G of 2 is 1. Yes. So we get 2 times, and that's 1. And the answer is 2. Finished. Okay, so here's my next example. By the way, I just want to make sure you understand. On the right side, this is just a segment. Here you have this one. It's just a quarter of a big circle. And also 1/4 of the small circle. Okay. All right. It says g of x, and by the way, this is the graph of f. Now, some kind of function g of x is given, and it says 1/2 x squared plus integral of from 0 to x of f of t dt. Part A, they want you to find g of 3. Okay, so you simply plug in 3 for x. So that would be 1/2 3 squared plus integral from 0 to 3 f of t dt. 1/2 3 squared gives us 9/2 plus from 0 to 3. I can tell that we have the two triangles from 0 to 3, and they cancel each other. So what does it tell you? You're going to get just 0, right? For that integral. So I'm going to get rid of these lines. All right, plus 0, and the answer is 9/2. So that wasn't bad. Now, if they ask you to find the g of -4, you would do the same thing. Now, let's try to do something else now. Let's try to find the derivative of g prime. So g prime at 3. Okay, so the function is g of x. I just want to copy it. 1/2 x squared plus the integral from 0 to x f of t dt. It says find the derivative at 3, but we need to find just the derivative of g of x first. And we're going to use the FTC too. So first of all, derivative of 1/2 x squared is just 1/2 times 2, and that would be just x, plus, and derivative of this, you apply the FTC 2, so that gives you just f of, replace t with x. No need to multiply by the derivative of x, because derivative of x is 1, so we don't really need to do anything here. I can put times x prime for you if you want, but you understand it's 1. So it's x plus f of x. Now we're going to find g prime of 3. So let's replace x with 3. So we get 3 plus f of 3. We get 3 plus, and f of 3. The graph is given, graph of f of x, and let's go back. At 3, the y value is -3. So -3. So the result is 0. Now I want to find actually, let's see, I want to find g double prime of 2. Okay, so the given function is, remember, g of x, 1/2 x squared plus the integral from 0 to x. You probably know it by heart by now. We want to find the derivative, but we already did find derivative, remember? Right here, derivative of g. Actually, I like this version better. So it's x plus f of x, right? So let's copy it. So g prime of x equals x plus f of x. That's what we got in part B. But it says find the second derivative. All right, not a problem. So we're going to do g double prime of x equals, derivative of x is just 1 plus, and f prime of x, right? Now they want you to find g double prime of 2. So let's plug in 2. So g double prime of 2 equals 1 plus f prime of 2. Now the function f of x is given. Now the derivative at 2. Well, derivative means slope. So what's the slope? Sorry, my dogs started barking. So what's the derivative of this function at x equals 2? So if you're here, so the slope is rise over run. I'm trying to figure it out. 1 second. Let me pause and see what the slope is. It looks like it's 3 down and 1.5 over. Yeah, so 3 down, and this is in the middle between 1 and 2, so in over. So I'm going to do this. I'm just going to put, stop. I'm going to put the slope of this is, since you're moving down, so it's 3 units, so it's -3 over, and over 1.5. So 1 minus, and 3 divided by 1.5 is 2. So the answer is just -1. I hope you're not confused. Let me know. I can explain better.